Today I'm going to talk about the question from 2018 Spring Qual. So, question 3. Let M be in the polynomial ring Z adjoining x1 up to xn be a maximal ideal. And we want to show that R mod M is a finite field. So, first of all, it is very obvious that R mod N is a field. Because this is an if and only if relationship, if and only if M is the maximal ideal in R. So what is remaining is just we need to prove that it is finite. So let's define the evaluation map pi from R to Z. So it sends every polynomial f to f evaluated at say 0, 0 up to 0. Yeah, so since it is an evaluation map, so it is a ring homomorphism. And so first of all, we know that pi is surjective, because we can see that this evaluation map just sends every polynomial to its constant term, and for every integer we can just find a polynomial such that its constant term is this integer. So therefore pi m is an ideal in Z. So Z mod pi m is well defined. So we can consider a new map, let's say pi tilde, and pi tilde sends is from R to Z mod pi m, and it sends every f to the coset pi f pi m. So similar as before, so pi tilde is surjective. Now let's consider kernel of pi tilde. So if we have some polynomial in the maximal ideal M, then pi f is in pi m. Then pi tilde f is equal to pi m, which means that f is in the kernel of pi tilde. So this tells us that M is a subset of kernel of pi tilde. But notice that kernel of pi tilde is an ideal in R, and also it contains M. So by the maximality of M, kernel 5 is either M or is the whole polynomial ring. However, a kernel of pi tilde is not equal to the whole polynomial ring. Otherwise, this pi tilde will not be surjective. Yeah. So therefore, we have proved that kernel of pi tilde equals to M. Therefore, by first isomorphism theorem, we have R mod M is isomorphic to the codomain Z mod pi M. Yeah. So notice that R mod M is a field. So Z mod pi M is a field, which means that pi m is an ideal is the maximal ideal in Z. So this tells us that, notice that maximal ideal is the same as prime ideal in Z. So pi m equal to some ideal generated by P for P prime. Yeah. So P is a prime integer. Therefore, Z mod pi m is just equal to Z mod PZ for some prime P, and this is finite. And so it tells us that R mod M is also finite. And this completes the proof.